Hello and welcome. In this video, I'm going to show you how you can use the simplex method in Excel. Now, if you've done a few of these by hand, we've pretty much only looked at sort of the maximization problem, or in a very standard form. Well, what if you have too many variables? And it's going to be a real nuisance to try to use the simplex method by hand, providing pivot points and redoing the tableau every single time. And what if you don't have a standard maximization problem? If you're looking for minimizing cost or something instead? Well, now it's time to take a look at how we can do this on a computer. Now, here I've got Excel and I've got a problem involving dolls. We've got this Hello Dolly ink, and there are three styles of dolls: Lexi, Amazy, and Dizzy. Each doll requires amounts of time on sewing, painting, and supplies. Now, we've got some constraints here. Sewing machines are only available for 197 hours. We've got 3,345 hours for painting. And for supplies, they're measured in pounds. Here we've got 417 pounds of supplies. And you can see that Lexi dolls require certain amounts of these materials and time. And we've got the same thing with Maisie and Dizzy dolls. So we've got three variables. And if you take a look, we've got three constraints here: sewing time, painting time, and pounds of supplies. You can also see that we've got profit that we want to maximize: $110 per Lexi doll, $125 per Maisie doll, and $20 per Dizzy doll. Lots of dolls here, I guess. How many of each doll should they produce? All right, well, sounds like a maximization kind of problem. Sounds fairly standard. We know roughly how long this might take to do by hand. How do we implement this? So, well, first of all, I'll have to show you how you can add in the little solver tool that we need. So if you don't already have it enabled, we can go to File in Excel here, and I'm using Office 365, but it's the same in any recent version of Office. And I'm going to go to Options, and along the left-hand side here, we have various different option menus, and we're going to go to the add-ins. Down at the bottom here where it says Manage Excel Add-ins, we're just going to click Go. And we need the solver add-in. And while you're here, I tend to make sure that we have the analysis tool pack because it definitely adds a lot of statistic capabilities. We don't need that for this particular application, but it would be very helpful for other applications. The solver is going to be good for our kind of optimization. Okay, now you don't see anything happening, but along the top ribbon here under the data ribbon, we should now have data analysis from the analysis tool pack and solver for the solver add-in. And this is what we're going to be using for the simplex method. Now it's time to start arranging a few things on the worksheet here. We're going to put in the objective function, and we're going to put in our constraints into the cells here so that Excel can find them. Well, first, I'm going to just put in a little section here for variables. Now, the variables in this problem are going to be the number of dolls. So we'll have, let's say, number of Lexi dolls could be x1, the number of Maisie dolls could be x2, and we could have the number of Dizzy dolls be x3. And we can set all of these to be initially 0, which is how we set up the initial tableau anyways. In a initial tableau, these would not be pivot columns, so they would all be treated as 0 in the initial tableau. Now it's time to put together our objective function and constraints. Now, for our objective function, we are going to be maximizing profit. And in a cell next to profit, we should put an equation here. So the equation should start with an equals, and we can see that this is going to be equal to a profit of $110 per Lexi doll. So 110 times cell, in this case C16, plus, and then we are going to get $125, 125 times the number of Maisie dolls, C17 in my example, plus, and then we still have to add $120 times the number of Dizzy dolls, which in my case would be C18. Now, we have an initial profit of 0. Again, this is kind of like how we start our initial tableau. And now it's time for some constraints. Now we have three constraints to worry about here. We have a constraint for sewing time. Now for sewing time, our constraint here is going to have to be a less than or equal to kind of constraint. There's only 197 hours. I'm going to leave a little blank space here and just put a less than or equals for my own personal benefit more than anything else. Less than or equal to 197. Now let's look at how much time each of the dolls takes. This is going to be our equation. So taking a look at a Lexi doll, it's 0.4 hours. 0.4 hours times the number of Lexi dolls, back to C16, plus 0.6 hours for each Macy doll, so that would be C17. Plus, we see Dizzy dolls are also 0.6 hours times, in this case, C18. And there's our equation for the amount of sewing time, and of course it is still 0, and 0 is less than or equal to 197. You notice that we don't have to put anything in with slack variables. Now, two more requirements here are painting time and supplies, and they can be done in a similar way. So you can see my painting time requirement: 8 hours for Lexi dolls, 10 hours for Macy dolls, and 9 hours for Dizzy dolls. And that is less than or equal to 3,345. And then for supplies. And so you can see 1.5 pounds for Lexi dolls, 1.2 pounds for Macy dolls, and 0.6 pounds of supplies for Dizzy dolls. Hit enter, that's 0, and that must be less than or equal to 417 pounds. If you want to, you can put these units in on the right. And now, again, if you want to profit, you can also change this into a dollar amount if you like as well. There we go. Now, this is just like the initial tableau, but in Excel. So the important pieces here are to make sure that we have the formula for profit correct and the formulas for our three constraints correct. Now it's time to go up to this data ribbon and see how we use the solver. Now, under solver here, you can see there's a different solving methods. It's really important right now to make sure we have this on Simplex linear programming. The objective function we should set as being the cell here, which is my B21, which is where I've got my profit function. And be careful, make sure if there's anything there, delete it first before you start clicking on cells. Make sure you've also got this set to maximum for this particular example. But you see how easy it is just to turn this into a minimization problem. The variable cells, well, those would be these 3 zeros that we've got initially. So you can just drag those ones, and I've got a range, C16 to C18. Now, for constraints, Excel does make this pretty easy to add many constraints at once. When we click Add, you can see there's a drop down here for the different kinds of inequalities. There's even constraints on being integers, where all of our constraints are going to be less than or equal to currently. So we'll just set the left-hand side here of sewing time to be less than or equal to, and then clicking on constraint here, 197. Now, if you hit OK, it's going to add this constraint, and then you'll have to get back to this dialog box. If you hit Add, it's ready for a brand new constraint. So we'll just go with another painting time constraint, less than or equal to 3,345. And we'll add that in. And this will be the last one. So this particular 0 for supplies needs to be less than or equal to the constraint 417. This time I'm going to hit OK because it's my last constraint, and I can see the 3. B24 less than or equal to D24, B25 less than or equal to D25, B26 less than or equal to D26. You can just imagine how many constraints you could just add in here and how easy it would be to make this a 20 variable problem. Well, we've got everything set. We can now hit solve. Okay, well, it sees solver did find a solution. All constraints and optimality conditions are satisfied. That's what we want to see. And if we click on keep solver solution, then when we close this box, it's going to keep the solution that it found. Otherwise, we can go to restore original values, and it will reset to what we had on our worksheet initially. It also gives you the option if you want to go back and change parameters, you can return back to the solver parameters dialog. I'll hit OK, and you can see there's a little bit of a mystery here as to what the profit is. Let's just expand that out a little bit. Obviously, this is a much bigger profit, $45,268.97. And it looks like Macy dolls are just the least profitable in the end. I mean, per doll, 125, but because of the amount of materials or time it takes, it's best for us not to make any Macy dolls. So there we go. That is the Simplex method in Excel. And like I say, how easy is it for you to just suddenly add additional variables or try a minimization problem? Now, you will notice that in my worksheet here, I have these less than or equal to symbols. They are just purely for my own benefit, so I can see the equation. Excel doesn't read those cells at all. And if I wanted to change a few constraints, I could go in and change these to new values, go back to solver, and you can see everything is still there from before. It'd be really easy to run this again. It will always start with your initial values. So I like to make sure those are 0 initially. If it starts with this tableau, it will try to find an optimal solution starting from that particular point. So it's usually good to reset to 0 and then try Simplex. And if you've made a mistake here, and if you just want to clear off everything in the solver parameters, don't forget you can hit reset all, and that will clear every single box, and you'll have to set the whole Simplex problem up again. Right, well, that is the Simplex method in Excel. So now you can do a linear programming problem very quickly. You don't need a lot of extra theory if you want to just make that problem a little more complicated and start putting integer constraints or a combination of less than or equal to's, greater than or equal to's. If you get really complicated, you may not be able to find an optimal solution, but yeah, it's definitely worth tinkering around with. Anyways, thanks for watching. I'll see you in the next video.